So in the previous Completing the Square videos, I talked about what to do if we had something like this, with a leading coefficient of 1. But sometimes that's not the situation we have. So what do I do if I've got a 2 or a 3 or a 27? Well, I'm still going to use my same templates for completing the square. I'm not going to try to worry about getting some sort of coefficient in front of the x in here. Instead, I'm going to isolate just the part of the equation that I can turn into a square from this. So in this case, because this is a positive, I want it to look like this. And my first obstacle is that 2. So what I'm going to do is I'm going to factor a 2 out of each of these terms. I'm ignoring the constant because we're going to deal with that at the end anyway. We're already going to be messing around with our constants. And even though I could factor an x out of both of these, because what I want is I want it to match my template, and my template will still have an x and an x squared in it, I'm not going to factor my x out because I have a specific goal, and so I'm going to use the mathematical steps that get to the goal I have. And at this point, that's to make this 2 not a part of what I'm doing. So 12 is like 2 times 6. So I can factor a 2 out of each of these. And I'm not trying to factor anything out of that because I don't really need that 5 involved. It's not helping anything. It can just tag along out there. So I factor that 2 out. And then I would have 2 x squared plus 6x plus 5. So now I'm well on my way to my completing the square pattern. I need to rewrite that so that it looks like 2bx, but I can do that from here. Six is 2 times 3. So now I've got both of the first 2 terms matching that frame. If I look at just this part, I've got x squared plus 2 times b times x. And that means that I'd have a b of 3. And that means that my b squared would be 3 squared, which is 9. Or 3 squared, I guess. Keep it either way. So I know the thing that I need in here is 3 squared. Well, I can't just add anything I want wherever I want, because this is an expression. It isn't equal to anything. But I can always add 0. So I'm going to add a special form of 0, which is plus 3 squared minus 3 squared. If I have 3 squared and then I take those 3 squared away, that's 0. And now I'm going to do something that's a little weird. And the reason I'm going to do that is because negative signs and square roots can really trip students up. So I'm going to take the time to actually put another set of parentheses around this to remind me that I need to square the 3 before I do my subtraction, because I have 3 squared take away a 3 squared. And so that needs to be taken away as a 9 rather than squaring a -3, which would end up adding 9. Because if I added 9, it would not be a 0 with this 9. It would be an 18, and that would not help. So just to remind me of my order of operations and that this is a subtraction and I need to do the exponents first, I'm going to have that parentheses there. And also, before I do much more work, I'm going to go ahead and deal with that exponent, just that one, because of negative signs and exponents being a very easy place for you to make a mistake. But this one I'm going to keep because it makes it easier to check that it matches the completing the square pattern. But this I'll go ahead and deal with. Well, now this part I could complete the square. It matches my pattern. But before I do that, I need to get rid of this. So what I'm going to do is I'm going to use the distributive property. I'm going to keep this whole chunk together inside some parentheses, but separate this chunk out and do the multiplication. So this 2 is still going to be multiplied by my entire first part, hanging out on the outside of the parentheses. But I'm going to go ahead and do the multiplication with that -9. So I use the distributive property, but only part of the time. I kept this part just like it was. This I distributed. So now the only thing I have in my parentheses is the thing that exactly matches my completing the square template. So I know I can rewrite this as x plus b quantity squared. So I have 2x plus 3 squared plus 2 -9 plus 5. Now I've got a little cleanup to do. Not bad, but need to go ahead and subtract 18 and add 5. Well, that would be -13. So now I've completed the square with a leading coefficient other than 1. And I ended up with this construction as a result. I'm going to do one more example in this video before breaking the video at that point and going on to the next video when things get even a little more complicated. But I have one more example for this video. So let's do 3x squared minus 24x plus 14. So this example is going to involve the other template because it's got a minus sign in front of the x. And also I just thought it was useful to see something other than a 2 as your leading coefficient. So I picked the next number, which is 3. So same thing as before, I'm going to factor a 3 out of each of these. And let the 14 just hang out over there. And then I'm going to rewrite this so it matches the middle term of the second thing in my little template here. 8 is like 2 times 4. So my b is 4. So b equals 4. So b squared equals 4 squared, or 16. So I do the same trick as before, where I can't just include 4 squared because I want to, but I can make a 0 pair here. And include that way. And I'm again going to put an extra set of parentheses around this to remind myself that I need to take away 4 squared rather than square negative 4. And those would get different results, and so it is important to keep track of that. I'll leave that 4 squared as is so it matches the pattern. I'll go ahead and convert that one to a 16 so that I can quit being worried about negative signs and squaring and order of operations business. Now I'll do that same partial use of the distributive property I did last time, where this chunk gets to stay, this chunk gets distributed away. So now I have a match for my template. So I can complete the square here, and this one will be x minus 4 squared. And the rest of it's along for the ride. Now I have a little bit of cleanup to do. Three times negative 16 is negative 48 plus 14. When I add those together, I would get negative 34. So I've once again completed the square, even though my leading coefficient wasn't 1. And I did that by strategically grouping things and then rewriting and 0 pairs and all those strategies I used before. I just had to start by factoring out, in this case 3, from each of these terms so that I could get this to match my template. And you really have hit the part of math where it's really about which is the most useful way to rewrite this, because you would do different steps depending on what you wanted it to look like when you were done. And there are a lot of different algebraically correct things you could do depending on what your goal is. But our goal is to complete the square, so we made the strategic choices that let us do that.